What's up, everyone? It's Michael here. I'm in gumloop testing out every single node. I want to make a series where I'm going to each node individually. Gumloop in itself is like a visual Lego block where you can put all these pieces together and play with different functionality that would previously require programming. And there's a lot of things to unlock in AI. So to start off, we're using the very first core node, asking AI. You can see it costs different credits to run when you use more expensive models. You can bring it down to 0 using your API. In terms of on the canvas, you have inputs and outputs for each node. Pretty self-explanatory. Any of the inputs helps confeed. You can give more context here, and whatever the response is for this Ask AI node is the text out. You can collapse nodes. When you have a bunch of them on screen, it's there. And we can see the main parameter here for asking AI is the prompt. And this is just like prompting ChatGPT, so this is probably the most intuitive one. So we can say, what are the best 5 pizza spots in SF? So this is the prompt. You can have as large of a context window as models will allow. We can pick different AI models. So we've got OpenAI's 4.1, 4.1 mini, O3, Claude. My baseline for most workflows is being able to use Claude. Claude Sonnet in particular. It's balanced, it's cheap, and it's fast. For fast, if you want the fastest, Google can be good. Both their Pro and Flash models are good. And then O3 is really good if you need highest intelligence. Perplexity, it's really interesting to be able to use Perplexity. It's API here in gumloop. So just like you would search Perplexity on the web to get live web research, this is like using an LLM with web search. We can see what the differences are. And they've got Meta's models, DeepSeek, Grok, Azure, and even Various, which would auto-select. Maybe try that. So for start, let's just see 4.1. Actually, let's even do 4.1 mini to start. Let's just start there. And then for a node, while this is the base parameters, when we click out more options, we have other functionality here. And this is getting really fun with the Ask AI module because you can actually use MCP servers. MCPs are just tools in themselves. You can learn more about them through gumloop. And so as we select that, we can actually have a few MCPs already created. So we can actually jump in here. We won't use that to start. We'll keep it simple. You can also use different functions. I haven't used this before, so let's see what this looks like. So you can pass an OpenAI function JSON schema to force a structured output. This is really helpful when you want specific outputs that matter for future parts of an automation flow. So that's really helpful here. You can catch responses too, which will help save credits if you end up doing the same thing multiple times over and over again. You can change the temperature. Lower temperature is more deterministic, where it's more factual. Higher makes it more random, more creative, better for creative tasks. You also can control the number of tokens, which is how much the output is. If you want to control size length. And we also have different inputs too, so you can actually variably control these if you wanted to. So if I click to this, we'd get an extra node up here. We don't want to do that. Let's just keep this super simple. Intro, outro. What are the 5 best pizza spots? We just walk through the node. Let's hit run. When we hit run, we get the run window over here. You can see how long it takes to run. Super interesting. We're getting a rate limit here. I wonder if that's mine or gumloop's. Maybe let's switch out. Let's switch out to Claude. Let's see if that was just OpenAI or if that's also, maybe it's on my side. So let's stop it. And let's run it again. Let's see if we get another rate limit. All the previous runs are also here. So we can see here if anything fails, what it looks like and debug it. Nice. Okay, so from, what are we in? We're Claude 4 Opus. Here are the 5 pizza spots in SF. Tony's, Classic, Golden Boy, okay. We're North Beach, Del Popolo, Pizza Shop, Pizzetti 211. Nice. Okay, so this is just like a general response for Opus is just like minimal thinking. Let's do Sonnet. Let's see if Sonnet runs anything different than like the general response that's in pre-training data. So the reason that these models are able to answer a question like this is they've scraped the web and they have all information. So if you're not feeding in data from a custom source or database, then they're just taking their best guess based off of training data. So let's see if it's any different. Okay, so interesting, right? So we're using a little bit smarter model. Tony's is the same. I think that's just baseline in SF. We're now getting like a lesser known co-op. So in terms of like thought, this is a little bit more thoughtful. This is the mission. Same thing, we're getting like Pizzeria Delfina, also super interesting. It usually might not come up as like one of the first ones. And also Flour and Water. So we can tell that like the quality of the responses are higher. They're a little bit more thoughtful. And again, we didn't add any data to it. We just picked a different thinking model. And so for that, let's now extend this to the largest thinking. Let's actually take time to think about it, see if the output is any different. And so depending on the model, you can choose based off of the kind of task that you want. And if you ever need help, you can actually ask an AI like Chat, Perplexity, or Claude to say, hey, give me the latest with each model, because it's almost impossible to keep up with the naming schema. So we've got 3.7 Sonnet thinking. Okay, it's pretty much the exact same thing that we saw before. So for a basic query in pre-training data, Claude 4 beats Claude 3.7 thinking, in my opinion. Let's do Google 2.5 Pro. Let's just throw intelligence at this question. And you can see with a larger thinking model, the time does take longer. So that's going to be one of the trade-offs. All right, as Google 2.5 Pro is cooking, let's see if there's going to be any other models. I think we'll stick with it. Or we'll do one Perplexity model just to see also the difference. Okay, this was cooking. Okay. A little bit of enthusiasm, of course. There's a diverse pizza scene. We got Tony's. Interesting. So it's even getting like some information from online. A little... Oh, wow. Even like little ratings too. The vibe, what to order. That's super interesting. So 2.5 Pro's got that extra like formatting in here, which is good to know. I like to test these, both the nodes and the models, just input and output to get a sense of it. And this is a lot of information. Google 2.5 Pro. Let's see what they have. Out of sight pizza, seller maker. Okay, so this is even a little bit more niche and specific than Sonnet 4 by itself. So tell that 2.5 Pro actually has a lot of information as it's thinking through its own pre-training data. And let's just test that against the most advanced Sonnet Pro reasoning. So Perplexity is now going to search the web to find the latest up to date. This is going to grab a couple extra resources, guides, and let's see, this should be even like more advanced than 2.5 Pro because it's going to be reading extra resources. And I'm going to pause the video here so we don't have to wait the extra time to fake it to see how long. Oh, wow. Okay, Pro is even quicker than 2.5. Perplexity is even quicker than 2.5 Pro. I didn't even have time to pause it. Okay, so we're asking for 5 pizza spots. We can see it's thinking. Let's make a must visit. Del Popolo, Pizza Boy. Okay, so it's interesting that, again, we're getting some more information with citations that we could pull out if we wanted those. And just from a baseline, the interesting thing is some of the most intelligence model like 4 Sonnet or 2.5 Pro, there's not much difference with this. So the training is definitely getting better, where previously, like 1 year ago, Perplexity would have been needed to get some more up-to-date information. So let's keep this here. Let's pick a faster model. We'll pick 2.5 Flash. And let's see what happens when we do function. Okay, so for function, it looks like we need an input here. So I'm guessing for a node, we'll do this in a future one. Yeah, okay. So for define function, when we want a structured output, like a specific JSON for the, maybe it's like the ratings, the price, what to order, we're going to have to use an input node here. So as you can see, we pulled this up. We have this input, and this input comes in here. Out of scope for this video. Stay tuned for a future one. This is a different node. We don't care about different nodes. We just care about what can we do in this node. So this one needs a node, closed for now. MCP server, this is already baked in. So let's see what I have. We have a calendar, YouTube. Let's even pull YouTube. And so now what I can say is find the top 3 YouTube video reviews. I don't even know if YouTube MCP can do this, but we're going to save this and run it. And so MCP specifically, again, it's just tool use for AI. Okay, let's see. Okay, Google doesn't even support MCPs yet. It's coming. Okay, we can use chat. We just got kicked out of chat. We can use Claude. Let's go back to Claude. Again, Claude 4 is the baseline, and Anthropic seems to be on top of it because they came out with the MCP protocol. So let's do this. And so now the goal is to see if we can actually just find YouTube videos with the MCP server. Don't know what the YouTube MCP actually does, so we can search that up afterwards. There's a lot of documentation in Gumloop and online, which we can figure out afterwards. And let's just see what this looks like. Okay, so when you use MCP in the Claude client on like desktop, you can see its chain of thought. This is a very underwhelming result. If we look at it, took 6 minutes to cook up this answer, and all we got is I will search on YouTube. Let's see what we got here. I will search on YouTube. Let me search more specifically. So for whatever reason, this MZP does not work. We'll try out future MZPs in future ones. Let's turn that off for now. We don't need another 6-minute response. Let's just change temperature right now. Let's just see what temperature does. We'll keep this. Let's see, temperature must be between 0 and, the text is off. Let's try 0. Let's just run that. Let's see, without an MCP server, let's hope this runs quicker. All right, so we got the basic answer here. Now let's do 100. Let's see if it gets creative. Let's see if it's something different than Tony's, Arsmendi, Golden Boy. Let's see if we get creative. Maybe this question isn't creative enough to change temperature. Oh, sorry, between 0 and 1, not 100. Just thinking about fuzziness sliders and other parameters. Temperature is 0 to 1. All right, Tony's. Okay, didn't really change the answer here. It's also because it's probably cached. So let's actually refresh it. So if it is cached, we want to make sure that it runs not on what was stored before. So let's see if that changes anything. Okay, similar answer. So at least for this kind of question, temperature doesn't matter. We can test that out in future ones. Keep it at 0 for now. Maximum tokens. Let's get a part of this is just exploring, changing parameters. One of the things I like to do when trying out a new platform is just to play with all the buttons to see what happens and just get a sense. So we can see 10 tokens, just about one sentence. The AI can't even finish it. Let's say reply in 1 line. Let's see if we tell the AI, can we actually get this thing in 10 tokens? Almost. Okay, I'm guessing we might need 30 tokens as the minimum to just get 1 full line out. 1 token is about 1 word. It's not equal. It's like a little bit less sometimes. But yeah, you can see here, cool, we got the summary right up here. If we remove this, let's get a sense of what 100 tokens looks like. It's just good to build an intuition by just trying things out and really get a sense of what's possible, especially as we start changing these parameters. Okay, so about 100 tokens is about half of the reply. So it looks like about 200 tokens should get us the full reply. And one of the things that I do usually in prompting is if I know I want a shorter reply, I'll include that in the prompt. I usually don't change the token parameters. Yep. So it's about 200, 250 to get like the full little extra bit at the end. But I'll just include here reply in less than 2 lines versus then do this. I find that this is helpful with parameters in prompting for general output, especially for automations. Nice. Okay. And we even got a different one in there. Okay. That is it for this intro. This went way longer than expected. If you like these videos, comment, let me know. Next up, we will look at the next node. We're doing node by node just to better understand gumloop.